welcome to this episode of the AI Show. I am back. I'm so glad to be here. I wanted to say hello to everyone, and thank you for watching. Last week you had the wonderful Icicle and Beatrice. They had some really good Ignite stuff. We're going to continue that. Momentum today. And the week before that, you had Cassie, who had a full takeover of the show. Where is everybody coming from today? Talk to me in the chat. I guess it would be in the chat. Excited to see where everyone's coming from. All right. So today, we're going to look. There's a new setting. Look at this setting. Such a good setting here. Such a good setting. I can do this now. Look at this. I feel like I'm living in the future. In the future. Today. What are we talking about? Hold on. And also, this app, the whiteboard app, has changed, which is super cool. It looks different to me. So I'm going to use this glorious Wacom tablet and this pen. Look at that. Okay. So today, number one. Oops. Oh no. What is happening? Okay. So today, number one, we're going to talk about something called Managed Online Endpoints with Sethu, who has the best name ever. It's seriously the best. I mean, how could you not like this name? Or in other words, as I like to call it, models to prod. So that's what we're going to be doing today for a little bit. Pretty excited about that one because there's some really cool stuff in there. And then number two, Avi, whatever you want to talk about. But we're going to continue with our rock, paper, scissors project. I'm thinking, and you check me on this, I'm thinking maybe, because, look, JavaScript is awesome. I'm having a bear of a time getting things to inference on the API side. So I'm thinking of changing the API from JavaScript to Python. Thoughts? So then I don't have to do bit shifting using Node. I just don't want to do it, okay? I don't want to do it. It's painful to me. Not because it's a bad language or anything. It's just that I just don't know how. I don't know how to do it. I don't know how. All right. Let's see where people are coming from. Let me Control Plus on my browser here so I can read what's going on. Hello, my friends. Looks like we have a couple of people. Jonathan R., welcome, my friend. We have Siraj Design. Hello. Vancouver, Canada, coming to us from LinkedIn, the more professional place. Advanced Christmas wishes, thank you. Or to anyone else who's celebrating any other holidays. There's a ton of amazing holidays. DF Meta. Hola, Señor Juárez. Bienvenidos a AI Gigante. Sorry, I was trying to channel like Don Francisco when I was growing up. Don Francisco was the stuff. And then finally, just to make sure to round things out, number 3. Let's go back over here to this handy dandy pen thing. Here we go. Number 3. Answer your questions. Answer Q's about AI. By the way, next week I have a talk at ODSC. So I'm excited about that as well. But this is what we're doing today, friends. Let's see what else. John Gomez from Claremont, Florida. Welcome. Again, this is all about. We're talking all about AI from India. Whew. It's like 12. It's like 11 o'clock at night there. Thank you for being such a trooper. Yeah, this show is all about AI and how I can be helpful to you with AI, amongst other things, right? Let's get a little background music on here. There you go. Okay, so I think it's time. I think we need to bring on Sethu. Sethu, are you there?
Hey, Seth. Yes.
So this is the part of the show where we just have a chat. Sethu and I have worked together for like a while now, right? How long has it been? A year?
Yes.
Feels like 20 years.
Yes. For a year at least, from the beginning of managed endpoints, from the public preview, private preview, public preview phases. Yeah.
It's such a good feature, friends. I will tell you, this is before the recorded part. The hardest part about machine learning is getting models into production. That's where most of these projects fail, right, Sethu?
Yes.
And it's something that Sethu is going to help us. All right, we have who else do we have here? We have Yaz Inba from Nairobi, Kenya. Beautiful place. I was there like 5 years ago, and I want to go back. It's really cool. All right, so Sethu, any questions for me? I think we're about ready to go. There's your screen. I want to make sure that we can see your screen. Okay, perfect. Everything's looking good. Now I need to move this thing over here, my notes. Any questions for me, bud? I mean, this is like how many times have you been on this show now?
This is my second time, Seth.
You could be running the show now, Sethu. I mean, you have the name for it.
I don't think so, but yeah, I have the name. Yes, that's something I'm going for.
The name is great. Like, me and Sethu are probably related somehow. Just because we're so cool. We both wear glasses. All right. Do you have any questions for me, Sethu? Are you ready to go?
I'm ready to go, Seth.
All right. So let me get my notes up here. And now we're going to do the professional part, because this is the part where and Sethu, are you okay staying after and answering any questions?
Yeah. Yes.
Okay. All right. So what's going to happen is I'm going to be like, you're not going to want to miss this episode of the AI Show, where Sethu Raman takes us through the wonders of managed online endpoints in AzureML. You're not going to miss it. And then I'm going to do this. And then we'll talk again, and then we'll be ready to go. Okay?
Sounds good.
All right, ready? All right, I'm gonna. Oh, and if you just look straight at the camera, if you want me to show your screen, just be like, hey, let's take a look at my screen, and I'll put your screen up, okay? And then what else? If you run out of things to say, stop talking, and I think we're good. All right, here we go.
Sounds good.
Here we go. Okay, I gotta zoom into this thing because I gotta be able to read what's going on. Okay. All right, you ready?
Yes.
All right. You're not going to want to miss this episode of the AI Show, where Sethu Raman shows us all of the wonders of managed online endpoints in AzureML. Make sure you tune in. Hello and welcome to this episode of the AI Show, where Sethu Raman is going to tell us some exciting updates for managed online endpoints in AzureML. Sethu, how you doing, my friend? Why don't you introduce yourself?
Hey, Seth. Doing great. Happy to be back on the show. So my name is Sethu Raman. I'm the PM product manager for the Managed Online Endpoints in AzureML.
Fantastic. So last time we talked a little bit about this feature. Can you get us caught up on what the feature is and maybe what's happened since?
Absolutely. So quick recap on the feature, on the capability for your viewers, Seth. So managed endpoints give users the ability to bring their ML models and deploy it in scale across CPU and GPU machines in a turnkey way. So they don't need to worry about the infrastructure. The system takes care of serving, scaling, securing, and monitoring your ML deployment. So that's what the whole feature is about. And so today we are excited to, so last week we launched a bunch of new features, and I want to share that today in the show. First one is auto-scaling. So users now have the ability to right size their deployments and reduce costs by using both schedule-based and metrics-based scaling. So this has been one of the most asked features from our customers. So that's something that we have released. And we also have released ML flow model format deployment. So if you have a model for ML flow model format, you can deploy it like without any code. We call no code deployment, so that is supported. We also support now deploying AutoML models in a no code way in our managed endpoint. So this is supported as well. And other than these, we are also like lighting up two new features. One is for interactive debugging of models before you deploy it in production.
Okay.
And then the second part is like a automated CICD safe rollout, capability.
I mean, there's a ton of things. Like some of them were super interesting to me. Well, all of them are, but the one that was most interesting to me was this notion of debugging. So I'm really interested in seeing how this works. Can you show us a little bit about how one might go ahead and use some of these features in an end-to-end solution?
Absolutely, Seth. So let me bring up my screen here. All right. So in this, the user story that I want to show here is somebody wants to deploy a new model into production without disrupting the current model deployment that is already running. So that's the user story. Of course, as step one, we need to develop when we talk about a new model, it can be changed to the model itself, or it can be changed to the code that you might have for feature engineering, right? Your scoring code or the environment. So in this case, I'm going to start with an example of changing the feature code and then how we launch a new model. So let's start with the first part of it.
Awesome.
So yeah, sure.
Let's pause right. Let's hide where it says StreamYard, if you don't mind.
Of course.
Perfect. All right.
So here I'm going to execute a CLI command. Here you can see I'm saying, hey, AzureML online deployment and create. You've seen this before from the previous show. And here we are specifying the deployment configuration file that has pointers to that has information on where's your code, what's your model, and the environment details, and then the endpoint name. So this is pretty standard on how you create it in the cloud. Now you have these two flags that we are passing. When we say -- local and -- VS Code debug, what's going to happen is the whole setup in terms of the whole image is going to be downloaded. Your model is going to be downloaded to be debugged locally. So let me just show what happens now. So when I click this, it's going to create the environment locally with a Docker container here, and it's going to launch VS Code that has access to all your code and all your dependencies. So that's what's happening right now.
So just a quick question. What kind of things are in the deployment.yaml file?
So three things primarily. I would say it has your code, where your code is, what your code is. It has your configuration of the deployment itself, like how many nodes, what is this queue you want, how many nodes you want. And then it has information on your model, which model you want to deploy, what's the version, and what's the environment details. So these are the things that are abstracted in the YAML. So
basically, it's a description of how this model needs to be run.
Exactly.
Okay, cool. And so when you're building these models, you mentioned that there's this codeless way to do it. What kind of code do you have to bring if you're making your own model? And then when we talk about the ML flow models, why is it that those ones are special?
Yeah, awesome. So let's take the question first, where if you want to write code, what kind of code you need to write. So this is a sample code, right? So here you see we have a score.py. We expect two functions. One is the init function, the other one is the run function. The init function is run once when the model is loaded, when your container starts, and then the run function is run every time you do a scoring operation. So here, typically people do cache their model into memory and stuff like that. And here, when the request comes in, you will apply feature engineering and do stuff and return your response, right? So this is the
can you hit Control+ on this so they can be a little bit bigger? There you go. So okay, now I'm seeing it. So the first function basically loads up the model because it's always just a file, and that only happens once at the beginning, and then the run is every time there needs to be inference. That's what's happening.
You got it, Seth. Yes.
Okay.
And you can have a bunch of dependencies. In the simple example, I was score.py, but a lot of our users can have like tens or 50s, hundreds of files, dependencies here. So that's all perfect. So this is a way of doing things with code, right? Then you have an option where you don't need to do code, where what we call no code deployment. So if you have ML flow case, ML flow supports different flavors. So you can bring in like scikit-learn, PyTorch, TensorFlow, all of these models. you can bring this in, and it's packaged as an ML4 format. And when you deploy this, we take care of the scoring logic, so that the user need not write any code there. Similar for our AutoML case as well. You just bring the model, and when you register the model, you set the model format as MLflow, and then when you deploy it, everything is just taken care.
Because MLflow and AutoML have a notion of like how the model was built, and so they have notions on how the models can be executed. But if you want to build your own model, you would write a script like this run script that we're looking at right here. All right, so what are we looking at right now?
So here we are looking at, so what we want to do, as I was saying, I'm changing some of the code, and I want to release a new version of the deployment without disrupting the current version to make sure everything is good, right? So here, let's assume that I've done some feature engineering code changes, and let's add something here to debug this. So I want to debug this and see if everything is okay. So here I'm just adding one extra statement here to say that, hey, model is loaded correctly, model loaded, right? And all I need to do is I just need to start the debugging here. So everything is loaded. When you executed the command, like the AZML deployment create, you just added a flag for local VS Code debug. And that's all we did. Now it's automatically launched the VS Code, and I have a breakpoint set, and I started the debugger. And you can see that the breakpoint is right now here. I can interactively debug this. So here I can see it's executed this, and I'm going to do this. Then you can actually see the model is loaded. So each and every line you can track the logs here, and you can put breakpoints in any of your nested code, and you can just interactively debug this.
So that's interesting. One of the problems I always have is I always get these things to run locally, but then it fails to run in the cloud because I might be missing something. How is this helping me with moving into the cloud?
Yeah, awesome question, because I know you know, like in the initial testing phases, you've been working with us very closely. So the whole idea is that's why you have this concept of local endpoint. It's downloading the whole environment is packaged as a Docker. So you when you test it locally, you have the confidence that everything is working, and update it, and then test it again. Once everything is done, then you deploy it in the remotely. You can expect that everything will work. So you save that time, that few minutes every time to deploy it remotely and wait.
So this right here that you're debugging is running as if it were in the cloud in the same environment, the same Docker container. Is that what this is doing right now?
Yes.
Oh my goodness. Oh, so and see, this is the thing where, because it all started up so fast and I was blathering with you, and then we ran it. I thought, because I run stuff on my local machine all the time, but this is running inside of a container exactly the same way it would run in the cloud, correctly? Is that correct?
Exactly, Seth. And in fact, in your deployment, that YAML, if you mentioned like, hey, this is my model and this is my environment, all of those are packaged and available for you to run here. So yes.
Oh my goodness. So now I can, with confidence, know that it's running, number one, and number two, know that it will run correctly. If there's any errors, I can suss them out before they get up into the cloud. Is that right?
Absolutely.
Even after we do this, though, there might be some weirdness when I deploy to the cloud. The one thing that I think is important is, how does someone do this safely? And that's another challenge, I think, because we don't want to just replace whatever endpoint there is. Can you talk a little bit about that?
Yeah, absolutely. So if you recall, the last time we discussed, we have the concept of like an endpoint and deployments. Multiple deployments can be underneath an endpoint. And then I'm just going to show that what happens here. So let's, why don't we go to the next steps and I show instead of I talk. So here we are done with this debugging. Everything is good. Now let's kind of push this in and see what happens. So we just need to commit this. Let's push it to our Git. I created a new feature branch to do this. Now I can just do git push. And now let's open the repo and merge this code and see how the whole thing is going to work. So let's see if this is done. Okay, all our changes are pushed. Let's create a pull request and merge this code. Oops, I didn't merge it.
That's okay. We can do it again. Go down and reopen the pull request there you go. Reopen pull request.
And then we merge it. So now what's going to happen is this has triggered, because we merged to main. This will trigger run here. So you can see this is GitHub Actions. This is a CICD engine, very similar to what if you use Azure DevOps or any other GitLab or any other CI/CD engine. It's very similar to that. And now you see that since we merged it, a GitHub action has been kicked off. So this is going to do a safe rollout. And you can see it just started this to a step-by-step rollout. I'm going to show you, since it's going to take a little bit of a time, I wanted to show you something that is already run recently. Okay, so what has happened is it is going to create a new deployment under the endpoint. So an endpoint is already running in production with one deployment that is taking traffic. Now we're creating a new deployment here. That's what this step of the GitHub action of the CI/CD workflow does. And next step, you can see that we do, after we roll out, we do sanity checking. Without even opening live traffic, you can actually hit the deployment directly to see if things are working, and you can test this. And now we open 10% of the traffic, live traffic that is coming in to this deployment. And after some time, we can validate. So you can open this and you can take this for 5 minutes, 10 minutes. Some of our users wait for a day before they do kind of a rollout to make sure all this are good. What do we mean by all this? In this specific example, I have two cases I'm checking. I'm checking whether there are no errors. When I open the traffic, there's no error to the deployment. That means there is no 3xx or 4xx HTTP codes or 5xx, right? It's only 2xx there. And similarly, we make sure the latency is within a X millisecond, whatever your threshold is. If these two are true, assume these are like your validation gates, release gates, then it goes to the next step. It opens 50% traffic, and it can wait for an arbitrary amount of time. And then this is opened up. And similarly, we check, do the validation, and then we open 100% traffic and wait for whatever time that needs to be done. And then finally, when we are super confident everything is good, we can delete the old deployment. So that's kind of the flow that a safe rollout looks like. And how this is made possible is by integrating with our metrics. So when I say latency is within X milliseconds, we validate here. There is a GitHub action here that people can reuse that goes and checks that for this, the metrics that are published are within in the Azure Monitor are within X milliseconds. So that's how we validate all of this, Seth.
I mean, this is really cool. It basically what you're doing is when you check in code, is it rerunning the entire training process and then producing a model? Did I see that right?
So it can be configured in many ways. So why don't I show you the why don't we show you some of the if we go here, so it shows the flow.
There you go.
Yeah, if is it okay, Seth, if I do a quick recap of what what we all saw?
Yeah, absolutely. Because I think like the process, showing it actually running was really cool, but I want to make sure it's crystal clear what is actually happening.
Yeah, absolutely, Seth. So this is the concept of endpoint and deployment, right? So you have an endpoint. An endpoint is an abstraction where the security is there, SSL is terminated, and you have a stable URI for clients to reference. And then you can have more than one deployment underneath an endpoint. So in this example, you have like two, and one is running CPU, another is running 3 GPU queues, and you can have arbitrary amount of traffic between these two. But if we go below, let's look at how the whole safe rollout concept works. So we have like version N of a deployment currently running in production that's taking 100% of the traffic, and slowly, and then we launch like VN+1. The new deployment in our case, which we just launched when I changed the code, it created a new version of the deployment, and I'm testing with 0% traffic. Then we open more and more traffic, and also there is documentation on how we do this, like using tags to actually specify to track which version of which deployment is prod and which is like a release candidate. So there is docs on this. I would encourage people to go through. But if you look at the safe rollout, to answer your question, Seth, how we have kind of laid out the pipelines in this repo. This is the key pipeline, right? This is a safe rollout pipeline, and it can be triggered. It can be triggered in multiple ways. So one way is a training pipeline runs, and the training pipeline itself can be triggered when a schedule based or a data set is updated and so on. And then the training pipeline can register a model that can kick off safe rollout, or you register or you directly merge to main. So in our case, if you notice, I did not change the model at all. I just changed the code. Maybe some feature engineering code is changing, some code optimization is done. even this can be a new deployment, right? So this is what the example we saw. But in this repo, we have examples where you can kick this off and you can see this as well. And the safe rollout itself, you can see the steps that we saw. We first create a deployment and sanity test it. Then we roll out 10% traffic to it and more traffic, right? But the key thing is you can see this approval gate at every step. We have an automated approval in this case. But easily you can add a manual approval as well if you wish. So that's our story.
This is really cool because like ignorantly I was like, oh, you changed some code and we got to redo the model. But the reality is that in some cases you're changing the inference code. There's no need for model changes. So this kind of pipeline, these kinds of pipelines enable you to rapidly iterate that way as well. Am I getting this a little bit better?
That's perfect. Yeah, that's perfect understanding.
Well, this has been awesome. Where can people go to find out more about these cool things?
So we have like three call to action links that are going to be shared as a part of this. So one of them is this this repo. The link to the repo people share. People can actually go and fork this. They don't need to even download the code or create a Python environment, anything locally. They just need to fork this repo and use some environment variables to point to their workspace and stuff, and they can get going. And then there's one more blog that we are sharing as a part of this AI show, where people can go and read about all the new features that I talked about, like auto-scaling, ML4 integration, and all of that, AutoML integration. There are tutorials that people can go through for each of these capabilities.
Awesome. Well, I put them up below. And then if you want to get started, there's a link right down below, Online Endpoints, get started. Sethu, this has been amazing. Thank you so much for being with us, my friend.
Oh, thanks for having me, Seth. Always
awesome.
Glad to be here.
Awesome. Well, we've been learning all about Managed Online Endpoints, some of the new goodness. Thank you so much for watching, and hopefully we'll see you next time. Take care. Boom. Good job, buddy. That was awesome. I was like tripping over words and stuff, Sethu. You were holding it together, my friend. All right. So any questions for Sethu? By the way, that pipeline that you were showing us, that's just a GitHub action, right?
Yes, all of these are GitHub actions.
Okay. And is it like and it's not anything specific to like machine learning? It's all just GitHub actions, standard GitHub actions, right?
Exactly right. So
what is
GitHub actions, and we have like CLI scripts to we use CLI to do all of these steps.
I see. And are these CLI commands like special? Like, what CLI are you using to do this?
And we are using the AzureML CLI. That's it. Very simple. AzureML online endpoint, and then there are a bunch of commands underneath that people can use. Actually, I can show you quickly.
Yeah,
there are many scripts. This is the simplest, the shell script. So if you look at the actual GitHub actions, it can be a bit scary because of all the syntax. So this is how the auto safe rollout looks. But in the end, even if you look at this, everywhere we are going to use the simple commands here. But if you want to really get the understanding of this, people just need to check out the simple rollout script. And you can see in the end, we are just using simple commands, script commands to do like a staged rollout.
That's cool. And then, I mean, because if it's command line like this, then you could do PowerShell type stuff too, right?
Absolutely. The most powerful part of this is, like there are two aspects, right? One is to roll out a step-by-step. But the key aspect that I want people to check out is how we do how we validate whether the metrics are doing okay and the latency is doing okay and things like that by using the validate metrics GitHub action that we created as a part of this. So here, when you use it in your pipelines, you basically say what's the ARM ID and what's the metric you want to monitor, and then it nicely monitors. It throws error if the threshold is breached, and nicely creates charts for you as artifacts in your pipeline. So in this example, you can actually see the threshold was like 80 milliseconds, but in this case, the new deployment breached it in few areas, in these two areas. So the deployment will fade. So that's the story.
So I'm looking at it. This is actually really cool. I hadn't seen this before. So is this action every time, between every step, it's asking a certain resource about its latency? Or is there messages?
Exactly right. You're exactly right. So at every step, so if you actually look at the this repo here, we can actually, I can quickly show you what's happening.
Okay.
If you go to the safe rollout pipeline, we will actually just call this nice sanity check. So let's go here. When we open, let's say when you open 10% traffic, we're going to be checking. We're going to be calling this this action to check. I'm just looking at where we are checking this. So validate errors within threshold. So
There
here
you
you can see, this is first time I'm calling validate. There are no errors. So I'm calling this GitHub action called validate metrics, and I'm passing all the information. So I'm saying that I want to check all the non 200s, 2xx. So this is what it is. That's all the code you need to validate. If there was no errors, similarly, you will have a similar one to see if there is no, the latencies are within the threshold.
That's cool. Here's a question from Kevin. Is there an option to deploy the endpoint via an ARM or Bicep template, or is it just a CLI for now?
No, absolutely. So we support REST, we support ARM as well. Bicep should not be an issue. We don't have an example on Bicep, and I can actually put links in the chat. So we support. So if you go here, there's a step-by-step example on how you can do with REST, and we're going to be publishing a doc on ARM as well.
Oh my goodness, great question, Oliver. And I think the cool thing is that because underneath these things, because it's just all Azure stuff, like ARM will work. Basically, is what you're saying, right? Because these deployments are Azure deployments in some way.
Exactly. Both endpoint and deployment are ARM resources. So that's why ARM will work, REST will work, CLI. And we also have Studio UI interfaces to do this.
Nice. Well, Kevin, you made Kevin super happy. Look at that. Bicep. Boom. Cool. Anything else you want to add or anything that we might have missed?
No, I think this perfect set. So the only thing I want to add is that we've added all of these cool. This has been like most asked features from our customers for managed online endpoints, and now autoscaling was one of the missing pieces. Now we have launched that to public review as well. I would love for our users to try this and give us feedback. And that's it.
Well, Sethu, you are a champ. We should have you on again and talk about some of the more of the cool stuff that you're doing, bud.
Absolutely, sir.
All right, my friend. Well, thanks so much for being with us.
Yeah, thank you so much. Bye-bye.
See you next time. Bye. All right, how about that dude? He's awesome. That was cool. There was some of the stuff I just hadn't seen before. All right. I guess it's time. I guess it's time for us to get. All right, so let me share my screen here. Boop. Boop. This new setting though, am I right? Can I move it? I can't move my face. No, I can't move it. Oh, wait. No, I can't move my face. Bummer. All right. So I'll be honest with y'all. I looked at this morning and was like, where did we leave off? And the reality is, oh yeah, absolutely. It was a great presentation. And he was like holding back too, because in the after part of the show, I was like, hey, show me the thing. And he's like getting into the stuff. It was cool. So as a reminder, we are building a rock, paper, scissors game. We built an AI model literally like in 5 seconds. And we spent the last like 4 months trying to get JavaScript to do the right thing. All we can say about that is so I was thinking we should try out like replacing this API. Here, let's just run it. We'll just run it. I'll show you what the problem is. So F5 here. What is this running thing doing? It's supposed to be running my here we go. It's supposed to be running my my Azure function. You can see that. There it is. Azure function. It's running the Azure function. Okay. So we'll load that up, and then I'll do a plus here, beep boop, a plus here, so that I can run the SWA. The SWA. I think it's SWA start dev or something. Yeah, SWA start dev. So now it's running the API. This is a static web app. There's the web part. We're using Next.js with React, and then the back end we're just using a Azure function. Okay. So now that's running. Let's go to the terminal. Okay. And then we go SWA start dev. Boop. Here we go. Open that bad boy up. Beep boop. And in theory, oh no, my camera. Where'd my camera go? Oh, okay, it fell over. This is embarrassing. Hold on, let me get my camera. 1 second. 1 second. 1 second. Where did it go? Oh, camera of mine. It was taken. That is not cool. Here we go. Oh, there it is. I found it. Don't worry, everybody. My camera is right here. I found it. Okay. My camera fell down. How embarrassing. Okay, here we go. Okay. And you're probably thinking, like, what camera? Seth, I'm looking at your camera right now. No, the camera I use for rock, paper, scissors. So we go over here. It's the HD Pro webcam. Right, and the idea was, here, let's put this over to the side, and you over here, wonderful, and here is the, this is the thing, right? So this is the thing that should be called. So when I go back to this camera and I put like rock and hit submit, it calls the API. And I think it returns. I think it returns here. Oh, where is the console? Here we go. Console. Here we go. This is what it returns. Oh, it got it right. The problem though is that we were squishing the image, right? I squished it because I'm a cheater. All of a sudden, there's like an empty chair. I got it. It had just fallen down. That's all. It just fell down. By the way, what's the latency? No, my cameras are all super in sync. How cool is that? Wonderful. Let's do paper here. Paper. Papar. It thinks it's scissors. Oh, what is going on? Why does it keep refreshing it? Stop it. Pro webcam. Pro HD Pro webcam. See, it thinks it's rock. What's happening is I'm squishing the image because we didn't know what to do. By the way, I love how Microsoft developer was like, talk amongst yourselves. Touche. Talk amongst yourselves. Did the kids borrow it? No. Apparently, I just knocked it over, I guess, in a fit of excitement. It's one of these random days. But so this is the problem, right? I don't want to squish the image, right? And when we're looking at the scoring that we did before, let me close this handy dandy thing. Why does it keep refreshing the page? Stop it. Don't do it. This is the way that we transform the image. Like, it's literally one call. And so I thought to myself, I said, self.
Self, you don't need to do this in JavaScript if you don't want to.
That's a good idea, self.
Why would you cause yourself all of this pain?
I don't know, self. So I thought maybe, just maybe, we might be able to convert this API from JavaScript into Python. What do y'all think? I mean, what does everybody think about that? Because then I could literally just use this stuff. But the question then becomes like, can we pip install Torch Vision in an Azure function? Let's take a look here. Stand by. SethJuarez.com. I wrote an article about this, but I don't know if it'll work with static web apps. Okay, here we go. Troubleshooting Onyx models, running locally, func start, glorious. Creating the function app. Yeah. Make sure the version matches. I'm just wondering, are we going to go down this rabbit hole and it's going to be like the worst thing ever? So, question, to do this kind of, is it enough for a free account? I think Static Web Apps does have a free version. Great question. So there it is, building locally. Building with native depths. Okay. Function app published. Okay. Notice how it pulls the appropriate Docker file from Microsoft Docker. But it works. Basically, a control of what. Holy cow. Pass, Seth. Why so slow? Let's curl it up. I know 3 seconds isn't a long time for me, but it ages. Why so slow? It turns out it needs a Number 2, better warm. Declared a set of global variables that, if none are initialized, I used the in-memory objects. It only happens the first time. In this case, the things we want to pass are session transfer much faster. First call 3. Oh, 0.2. Hey, yo. Review. Okay. So it looks like past self, Seth, thought of this. Another question. You should just put the package in the requirements.txt. Yes, but Torch Vision is ginormous. But we'll try it. And so that's what I think happened when I did this the last time. So we might not be able to. Let's see. Okay. There's a way to deploy building. See, this will force me to build locally. I wonder. All right, let's take a look at this. Azure static web apps docs. I wonder. Here we go. Docs. I wonder if there's a way to specify. Here, let's take a look at the code here. Here, let's go to the GitHub bits. And this is where API location, output location. And I wonder if there's a way to add some API commands to build it properly. Let's take a look. App location, API location, app build command, API build command. Okay. For Node.js, you can define a custom command to, but see, this is all so Node-ish. Okay. I wonder if you can add an API, create an API. See, but it's all JavaScript. Well, kids, I may have to learn how to do bit shifting with JavaScript because I'm not seeing bring your own functions. Consider an existing Azure function, blah, blah. Once linked. Oh. Huh. This is basically saying that I can create my own deployment. So maybe we just join these things together. I mean, the other thing we could do is ml.azure.com is I could just defer, defer. Well, and what does Seth mean by defer? Like I have an endpoint here that has what is this? Oh, this is the wrong one. Let me go home here. Home. No. I want to go to this workspace. Okay. I have an endpoint already. Remember that? I think. No, because where did our Rochambeau stuff go? Because maybe what we can do is I can just make Azure do the endpoint, and I just call it. So here's the Rochambeau experiment. And I think we decided that VGG19 was the best one, but it was ginormous. I wonder if we can do what Sethu just showed us. Right? And then we just make Azure. Let's just do what Sethu showed us. Why am I going through all of this grief? I'll just do what Sethu showed us. All right. I think I'm going to do that. Let's just do that. Because then I don't have to worry. Oh, I clicked the wrong thing. Then I don't have to worry about, I can just have the API be dumb and pass along. And then I can use a model of whatever size I want. I think I'm going to do that. Okay. I think I'm going to do that. Let's make a new workflow. New file. AI model build dot YAML. Okay. I think I actually did something like this already. Oh, look, I already did something like this. Let me go to let me open another, because I did a rock paper scissors demo. I already did most of this work. This is just absolutely ridiculous. I've been making it hard for myself the whole time. Huh. I'm gonna do it. Let's take a look at what this looks like, though, because I want to make sure, because I did a similar thing. So let's see. Let's go to github.com, Roxy, and let's go to. So what would Sethu do is right. He would stop working on JavaScript, is what he would do. Because I did. This is a demo I did. Looks like something broke here. But here's the full deployment pipeline. I'm just going to do this. Why am I making it harder for everybody? Let's take a look at what the workflow looks like. This is the thing I just looked at. I think it broke, though. Let's just go to Sethu. Sethu's thing. Setter. I think it's it. What was the link? Oh gosh, where was it? I need to open this doc here. Let me open my doc that had the, because I store the links, right? So let me find it. Come on. Portal.office.com. All right, here we go. Let's just build the thing that Sethu did. Oh, it's not there. What was the link? There was like a, oh, hold on. I think MS Dev. Okay, it's github.com, Sethu, safe rollout. github.com, Sethu, safe rollout. I'm like, oh, shoot. Safe. Let's see. github.com, Sethu, safe rollout. Boom. Simple rollout. Okay, let's take a look at this. Let's just do this. I mean, right? So basically, we need to get the model. We get the model version. There's the endpoint. Okay, let's just do this. All right, let's see if we can get this sorted in the next little bit. What I'll do is I'll do training .yaml. And what I'm going to do is I'm just going to take this one and I'm going to copy it and paste it in here and see if we can't fix it so that it works for us. Okay. Rochambeau CICD. Okay. So we want to do only for the AI paths. So AI / like this, because we don't want to build on anything that's not AI related, because then we don't care, right? The app name is going to be Rochambeau. Okay. So we add the extensions. We need our Azure token thing, which we'll have to build. I'll have to get my AML workspace and RG. Now let's go to AI here. What does this cloud job thing? Here it is. So AI / how I did it up there, by the way? Yes, I did. .ai cloud job.yaml. Set default workspace. Sign in. Oh my goodness. Oh no. I am logged out. Oh no. Sorry, I've been watching some oh, I'm signed in. Some friends recently. Okay, we want this one. Hal, yes. Yes. Hal indeed. Yes. Okay. So let's see, why isn't it like this? I think this is what we did before and it was fine. Okay, so now I think these are environments. Do we still have those environments in there? I think we do. Let me go here. Let me look at my environments. Yeah, so I have a PyTorch Lightning and a PyTorch Lightning for deployment, which is cool. So we can use those. Okay. Cool. Okay, so that environment's good. Environment deploy is, why isn't it like this? Maybe my schemas are wrong. Okay. Deploy. Okay. I think this is what's changed now. So these are the depths for, okay. So I think this has changed now. So let's go to Sethu's things and let's see if we can figure it out. So here we go. So here is when we create an online deployment. We have a deployment file, and that deployment file is endpoint deployment.yaml. Endpoint deployment.yaml. Okay. So we'll take this and we'll make a deployment file. We don't need this one. I'll leave this one open, but all right, so here we go. So we have, let's make a deployment. So new file, deployment.yaml. Boom. The model, I wonder if we could change this. So the local path, how did I do this over here? Because there's probably some under this. We'll split right here. And then we'll close this. There's so many red things. Okay. So we have a name. Okay, this is the deployment. We should probably do this app insights things because I think it's important. The model code configuration. So it looks like it's ... up for us. The environment is just this thing. So we don't want to do this because we already have our built-in environments. Doop, doop. Deploy. Instance type. I want one with a GPU. So let me go, because I know I did a deployment with the GPU on this one. So stop looking. Stop it. Don't do it. No. Aquí no. Vamos a ver. Here. NC6v3. NC6v3. Okay, so this is a standard deployment thing for us. Oh, I put here. Okay, so this is how we do deployments for us. Nice. So now we have a deployment file. We got that. Looks like we got that. Let's take a look at the endpoint file here. Oh, snap. This is really easy. I mean, do we even need this? Safe rollout. Scripts. Simple rollout. Yeah, so basically it's like, is the endpoint there? If it's not, then we add it. But do we even need an endpoint? But let's see how I did it before in the training here. So we have the running. This runs the job. This runs the job. This registers the model. Registers AzureML job download. Right. Outputs path run. Mcdir. Okay. And then here's the endpoint creation. Endpoint.yaml. All right, so let's make one. Okay, new file. Endpoint.yaml. I think we're going to call this Rochambeau endpoint. Oops. Rochambeau endpoint. Okay. Cool. Looks like this thing is deprecated. So this is happy. This is happy. Wonder why the job isn't happy. I wonder if it doesn't need a target, if it knows that this is the compute. All right, let's take a look at the command job here. By the way, how's everybody doing? It's been a couple of weeks, huh? Oh, there's people talking at me. So do this kind of application. Is it enough for free account? Oh, we talked about that. You should just put the package. What should say? Will that image have PyTorch in it? Yes. The image that I'm building right now, you can see right here, over here, that the dependencies for deployment have everything I need. Right? They have the torch vision, blah, 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 all that stuff. So good question. Good question. Oh, I forgot. I'm still running the SWA thing. I can turn that off. Goodbye. Goodbye. And you can stop. Crash. Okay. But there's something wrong with this job. It's not liking it. Let me go and see what Sethu did. What would Sethu do? Oh, I loaded up the thing, but I still want to see what Sethu did. Safe rollout. You did train job. Let's compare. So Control Z out of the whatever muss we made here. And let's see what they have here. So for me, it's basically this. Doop. Oh, I love being able to put it on multiple lines too. So let's see. Doot. Nice. Okay. The other thing is that they have inputs. Oh, they have inputs too. And it's data set. So inputs, for us, it's training data. And then the data set would be this one. And I think the mounting mode is what I want. Okay. The environment is going to be this one. Our compute is this one. Experiment name is Rochambeau. Display name Rochambeau job. This we don't need. I think this is what we have. All right. Happiness. Oh, wait. Not this. Okay. This is much happier. And then I can looks like I have experiment name first here. I'm just trying to see why this is different and what it is that this we can move down here like this. Code. Local path for us is ... forward. The command is this. We don't need this. Inputs. Yeah, see, compute is just one line now. Compute. And then environment. Yeah. So what is it that it didn't like? Oh, because I think the compute. Yeah, I think the compute, it doesn't like target anymore. This is brand new. Inputs, okay. And then, okay. Let's see if it likes this. Our job is happy. Okay, I like this better. This actually looks a lot better. So that's our job. Let's go to our training.yaml. Just to make sure it's working, just to make sure we got the thing. So AZML job create file, AI cloud job. App name, GitHub run stream. So this is good. We just fixed that. The next thing is to register the model. So it downloads the job, AZML model create. Okay, so that should be the same because there's no YAML file. This is here to check if there's an endpoint. We don't have an endpoint.yaml. Oh, yes, we do. Yes, we do. Look at that. Right there, endpoint.yaml. We got that. I guess it's going to be .ai /AI. So I need to make sure that I find these because it's gonna blow its lid. AZML job. This is okay, right? Because I'm just downloading things. This I fixed. Okay. Cool. We just did that. Now it's time for getting the model versions. Okay. And then what is this rewrite business? Okay, this is now the new stuff. This is the stuff that Sethu was literally just showing us. Okay, so this is the part that we need to fix, because I think this is all hokiness. This is all hokiness because I hacked it together before because you couldn't do the things that you can do now. So let's go to safe rollout here. Let's go to script, simple rollout. And we got the model. We got this part. Okay, what am I doing here? ¿Qué pasó? So this assumes that I've already created an endpoint. Now I'm rewriting the thing out. So what I'm gonna do, I'm just gonna follow what Sethu did. I'm just gonna do what Sethu did because I think cool. Let's just do what he did and see what goes on. So echo the model ref out. Deployment name, create deployment name, endpoint name. Let's go back and see what our endpoint is. Here it is, appname.endpoint. This is our endpoint name. Our deployment file is going to be AI cloud deployment, right? We're going to set the model to this model ref that we just got. And we're going to give this a deployment name. All right, what did he do for that? RC deployment name is this thing. We could just do Rochambeau dash. We can do app name dash. App name dash number. GitHub run ID. Let's do that. App name. Hold on. I think I'm doing GitHub run ID too over here. Here. Since this is a deployment, it can be named the same thing. So I'll do that. So let's go down here. Endpoint. Create. Boop. 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 Okay. Raw deployment equals blah, 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 online endpoint.show, tags up. If there's no prod deployment, then tag the current deployment. It says traffic. So the new online endpoint update, we're updating this endpoint. We're setting the traffic to this, to 100, and we're setting the tag to that. Boom. Otherwise, we need to do a little something else. All right, so let's go over here. Let's go over here. I think that's it. Because what happens, it will keep adding endpoints. Well, no. If there's more than one. What should we do if there's more than one? let's just roll out 10%. Let's just roll out 10% in this, and then we can think about what we want to do after this. I think there's an else, so else. AzureML endpoint name, which is this app name.endpoint. I'm going to set the traffic of prod deployment to 90 and our RC deployment, which is this thing. No, is it app name underscore GitHub run ID? Yeah. Why don't I do a dash? Dash. So I use a dash there. So we're setting the traffic to 100% here. Otherwise, we're setting the traffic to 90/10, which is cool. And then that means anytime we want to change the deployment, we have to go in there manually, which is good, right? Because we don't want. I don't think I need the exit 0. Okay. Modify traffic to siphon 10% to new deployment. Doop. Okay. Oakley dokley. I think we've done it. Now we just need to have our secrets. Los secretos. Okay, the first secret is need the Azure token. So what I'm going to do, oh, by the way, here we go. Did Sethu mention in his presentation what the online endpoints, let me read this here real quick. Did Sethu mention during his presentation what was online our host on? Is it just a VM or is it a container host or something like AKS? Or it's a container. Pretty sure it's just a container thing. So yeah. So right now I need to get this Azure token. Here, let me show you. What I'm doing. But then I gotta get these tokens and I can't show them to you. GitHub.com. AI Advocates Rochambeau. Oh, maybe I already did this. I'll go to settings. And where is the secrets? Shh. Oh, look at that. Environment secrets. New repository secret. And what I gotta do is we need here this Azure token. And I got to put the Azure token in there. And for those that are wondering, what the heck is that? This is a GitHub action thing for Azure Login V1. Let's see if I can show you where we get that. And then I got to hide when I do this. Okay. GitHub. Visit connect to Azure. Yes. Thank you. Okay, here you go. This is how you do this. So what I'm going to do is I'm going to write this command. I'm going to run it, but I'm not going to show you the output because it's a secret. It's a secret. Okay. Doop. We'll call it Rochambeau. CICD. Role contributor. Scopes. Subscriptions, SDK auth, space. Okay, so I need to get my resource group. My resource group's name is robots. Oh, I gotta go over here and I gotta pull this stuff out. I don't know how much of this I should show you. Portal.azure.com. Here we go. And I've got to run this command with the right sub ID, copy out the thing that I want. And what I'm gonna do is I have to put this over here so that no one can see it. Okay. Okay. Logging into Azure Speaky. So let me double check HAL, which is my okay, I got my sub ID. There it is. Let me pull it out. Put it here. Paste as plain text. Oh. Uh-oh. SDK auth will be deprecated and removed in future versions. Okay. I got the thing. I got the thing. Copy. Okay. So I added the Azure token. You can see that right there. I'll close this. Well, I'll leave that open just because I might want to save it. Let's save this. Okay. Boop. Okay. So that is gone. Let me close this. Cool. What was the next thing we needed? So I got that secret thing out of the way. Azure token, we got that. AML workspace and AML resource group. I think that's it. So those ones are easy. I can add those ones right now. AML workspace is HAL. And then the other one was AMLRG resource group. And that one was robots. Robots. Okay. 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 Cool. Okay, we got that. We got that. Now, the last thing we need to do is we need to make sure that anytime there's a cloud, there's a .ai in front of it. Okay. Let's check it in. Let's check it in. Let's check it in. And let's watch the magic happen. Thank you. Hit status. What changed in... Oh, yeah. I don't want to check that in. It's my workspace in there. Training. Okay, we added that. Deployment is new. Endpoint. TIS also new. And then this we fixed. Cool. Git status. Git add dot git commit -m added CICD for Rochambeau model. Boop. Alrighty. It takes a little bit because it always asks me for my password because I sign all my commits. There we go. Git push origin main. Boop. GitHub.com. Here we go. Oh, geez, it's doing this. Oh, I should tell it not to do this. If let me fix this too, because for some reason it looks like let me close this here. It looks like I should add some paths here. Add some paths here, because this does not need to on push. We only want to do this on API and web. API. Wait, what the freak? What is this? API start, and then same here. I think there's something wrong with this. That's why it didn't do it. I wonder if this will fix it. You may stop. You may stop. Stop it. Stop it. Okay. GitHub action paths. Here we go. That's why it was in quotes. Okay. When all the path names match patterns and the path ignore, the workflow will not run. GitHub evaluates path. Okay. If at least one path matches a pattern in the paths file, the workflow runs. That's why it didn't work, because my quotes were off. And the thing about it is I just need to do, okay. I don't need to do this dot thing. So I can do this. Okay. That's why it didn't work. Boop. Okay. And then for this, I don't do this either. Let's take a look here. ** /*. Yep. No. And then we'll just. Okay. Okay, that'll do it. Git status, git add dot, git commit -m, correcting path for workflows. Here we go. This is going to do it. Have any good resources on signing commits? I did it so long ago. I don't even remember how I did it. Just my machine is set up that way. All right. So in theory, we should have some workflows running. So static web apps did not do. Oh, this is the one I canceled. Action. actions. So I can delete this one because I canceled it. Why isn't this one working? This workflow has no runs yet. Why not? Why don't you? On workflow dispatch and on push. Why isn't this doing the right thing? Let's go to Sethu's safe rollout thing here. Let's do this. Safe rollout, GitHub workflows, auto safe rollout. I know why. Wait. I know why. And it's gonna be so dumb you're gonna laugh at me. If at least one pattern, at least one path matches the patterns. This example runs anytime the push event includes a file in subproject directory or its subdirectories, unless the file is in the docs directory. Anytime you push a JavaScript file. Okay, so I know why it's not working because I'm a dumb. I haven't changed any files in the AI thing, so that's why it's not changing anything. So let's go to job and let me add. Now it's different. Commit -m testing cloud trigger for AI model CICD. Git push origin main. All right. There it is. Sorry, I got excited. Okay. Okay. Here we go. ml.azure.com. This is the part I'm worried about. Once it gets past this, then hopefully, yeah. What do we got? Oh, it did log in. Nice. Oh, nice. Something just happened. Oh, here we go. Okay. Things are happening. Oh no, the endpoint failed to run. Oh. Let's cancel the workflow. Let's stop this. Cancel. Yes. This should be online endpoint. Let's see what Sethu did here. We're gonna get this. Scripts simple rollout. Online endpoint. Not online endpoint. Not online endpoint again. What? This. Okay. The endpoint name for us is app name endpoint. Okay, if endpoint exists, then we do this. This is the endpoint name, and this is the endpoint file. Okay. Okay, this should fix it. So online endpoint, cool. Deployment, online deployment. Okay, cool. Online endpoint, update. Okay, cool. I think this is the part that messed this up. So let me go to job here and take that line out again. Git add dot and git commit minus m. Hold on, I don't remember, like, what did we stick with the VGG19? Let's do VGG19. VGG. Git add dot git commit minus m corrected online in GHA. Okay. We don't need this one. Oh, yes. Oh, dokily. Okay, let's see if you got it set up correctly. Oh, yes. Thank you, Microsoft developer. That's right. December 7th, 9:30 to 11. Check out Put Responsible AI into Practice at aka.ms/Azure Responsible AI. I will be interviewing a couple of people about some of the responsible AI stuff that you can do in order to use AI responsibly. It's going to be pretty cool. I looked through some of the notes today. I'll be looking through some of the notes later on. It's some cool stuff. Now that AI is starting to get more mainstream, it's important to make sure that we do this in a responsible way. Okay. So it looks like the endpoint is getting created now. Ah, yes. Summary. There we go. Endpoint's created. Experiment is experimenting. I wonder if it will get mad if I give it the same job name every time. I don't know. Okay. So last time this took 7 minutes. Maybe I should unshuffle net. Still running. Preparing. Yep, there's the command created by service principal using dataset version 1, Rochambeau. PyTorch Lightning version 6, GitHub repo. There's the job def, full job def. Fantastico. Raw JSON. Yep. Nice. Okay. All right. So this is going to take 7 minutes. And then I don't know how long it's going to take to deploy. Hopefully the deployment works. No, we don't need this anymore. You can go away. You can come back. So now, in theory, let me go to endpoints here. In theory, I should be able to just consume this. I'm going to regenerate my keys, but I'm going to do that in a second. But I bet I'll be able to just call this from my backend. My API backend. I don't have to worry. I'll just pass it off to this and let it do its thing. It's a GPU anyways, right? GPU. Anyways, here I'm going to refresh these keys here real quick. Because I made a boo-boo. Regenerate. 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 Okay. Those keys are no longer accessible to you. So we made an endpoint, but there's no deployments. That's cool. That's cool. Let's go to the experiments here. Rochambeau job. Still preparing. Let's go to the logs here. Oh no. Does it have to just... I hope it just pulls the image. I have to build it. Because that would suck. All right. Any questions as this is going on? I'm basically saying I'm tired of making JavaScript work. I'm just going to let Azure manage my AI model deployment. That's all I'm going to do. Because I don't want to do it. And then what I'll do is from the API backend over here, when I get the image, I'll just forward it on to I'll just forward it to AzureML and get rid of all this stupid code. I don't need it. The only reason why I need a backend is because I want to protect the key, and the key can stay in the backend, right? So there you go. And then I don't have to have any of this garbage, right? None of this garbage. No lo quiero. I don't want it. Let's remind ourselves a bit on how we're passing the image back, though. Pages, index. Media track settings, set message, set frame. I'm sending the actual array, which is kind of dumb. I could just send the base 64 image. I could just send the base 64 image. And then what I could do is I could actually base 64 image will work. And in the score, I just have to here, I'll just have to get a base 64 image. I think I wrote this code, actually. Because I knew I would have to do this. And so I did it in this one. Oh, pass Seth. Pass Seth is so happy, or future Seth is so happy with past Seth. Yeah, see? Yeah, this score file is way better. Way better. I'm just gonna steal it. Because take a look at this. So what happens is I don't even think I don't think I even do error trapping on this one. Oh, I do. I do. I'm not that dumb. Not that dumb. But I think on this one, with this one, I send like actual base 64 images. Look at that. Yeah. I'm going to do it. Just going to take it. It's my code anyways. I'm going to need these test images though, huh? Full image, test image, Control C. And then we'll put that in Rochambeau. 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 AI. Heck yes, this is way better. Because now what I can do is when I pass, I can literally pass the base 64 image. I don't have to do anything, right? Like if the image starts with HTTP, then I load it as a request. If it starts with data image, I basically just split the base 64 image, decode it, put it into pillow, right? A pillow image. Or I just decode the, like if data image is in there, if it's not great, then I run the transformation. What transformation, you ask? The one that I've been trying to figure out how to do with Python, with JavaScript. And I don't want to. I don't want to. I don't want to. There you go. There you go. Okay. All right. Okay, let's see where we're at here in terms of, is this still building the friggin' image? Come on! Why does it have to build a whole image? Hold on. Did I do the job right? Let's see here. Job. Yes! There should be a pre-built image. Why is it rebuilding it? Why do I sound like Seinfeld? Why is the image getting rebuilt? I don't know. I sound like Seinfeld sometimes. Or that dude from Everybody Loves Raymond. Why? I even got the background music playing the right way for this part. Yeah, it's going to take forever. It's going to take forever. Let's go here. Like what? How long has it been running already? Still preparing. It started at 34. It's been 10 minutes already. No! All right, well, it's going to do what it's going to do. I think what we can do is, what we can do is we can start planning on what we want this app to look like. Because I'm hoping that eventually there'll be enough people playing this. And then maybe I'll talk to our lawyers and be like, hey, if people want to submit images so that like it works for them too, what do we have to do legally to write, you know, and it might be instructive. I'll ask our peoples. And then what can we do, for example, to make sure it's ethical? That's what I want to say. Ethical. And then we can build a whole app, right? But now that we've abstracted away the AI stuff, it's really nice because then we can figure out how to go from people submitting their own images, right? To this every week, this thing gets trained, or if 100 new images show up, then we retrain it. You know what I'm saying? I mean, I'm pretty cool. It would be pretty cool if we did it that way. And then we can make the app really nice and people can log in and store their pictures or remove their pictures. Oh, that's an interesting thing for ethics-wise, because we could delete the pictures. Yeah, it would be the very first ethical AI way to play Rochambeau. Oh, and then what we could do, we could make it so that people can log in together and play against each other. That'd be cool. I'd pay to see someone play. Mostly with hearty high fives. Hearty high fives. All right. Are you still? Oh, goodness. Oh no. No. Still building the image. Oh, sorry. It's not warm. I haven't done this in a while, and so it's just not warm. Yeah, I wonder why it's rebuilding the entire image. No, I don't understand. Maybe we'll do components next time too. That would be cool because it's new. They told me to look at it now. So maybe we can learn together. Okay, well, that's what this is doing. I'll just let it run. It's probably not going to finish in time. Bummer. All right, let me look at... let me see if I can find the responsible AI stuff. We can start to look at it here. Uh-oh. No. No. Let's take a look at the responsible AI stuff. No. There you go. Okay, here we go. Flagged email. There was a where is it? Dismiss. Mention. Oh, here we go. RAI. No, this isn't it. No, this is... I can't find anything. I know what it is. Fair learn. This. We're going to start playing with this too a little bit. Improve fairness of AI systems. FairLearn is an open source community-driven project to help data scientists improve fairness of AI systems. Fairness is socio-technical. Wow, that's a $5 word. Agreed. Fairness of AI systems is about more than simply running lines of code. In each use case, both societal and technical aspects shape who might be harmed by the AI systems and how. Let's see how we do this here. Pip install FairLearn. Install. But FairLearn is still evolving, so and documentation may not work with every version. Okay. The FairLearn package has two components: metrics. Metrics and algorithms for mitigating unfairness in a variety of AI tasks along a variety of fairness. FairLearn in 10 minutes. For this example, we use the UCI adult data set where the objective is to predict whether a person makes more or less than $50,000 a year. Okay. Nice. We're getting some data. We're looking at the gender distribution. Obviously, the data is imbalanced. 3-to-1. Well, ish. Yeah, see that? Evaluating fairness. Firstly, FairLearn provides fairness-related metrics that can be compared between groups and for the overall population using existing metrics. Okay, so we're going to do decision tree classifier white box model. Classifier.fit. There it is. We can do prediction, a metric frame. Is metric frame... Oh, it's from FairLearn. Cool. So the metric frame metrics is the accuracy score. Where's this coming from? Oh, here we go. Accuracy score. Cool. The true and the prediction. And the sensitive feature is gender, obviously. Oh, wow. That's cool. So right away, we're noticing that there's higher accuracy for women than there is for men when it comes to over 50,000. Now, that may be good or bad. That needs to be addressed. Additionally, Fairlearn knows how to offer other standard metrics built in, such as selection rate, i.e. the percentage of population that has a 1 as their label. Okay. Fairlearn metrics, selection rate, metric frame, metrics, selection rate. What? Cool. Overall. What's the overall? By group. Oh. Okay. Fairlearn has a lot of standard metrics, such as the percentage of population that have a 1 on the label. So only 16% of the predictions are assigned to label 1. It looks like if you're a woman, only 6% is assigned to 1, while if you're a man, 21% is assigned as a 1 over 50K. So notice that this was like, oh, this is actually pretty accurate for women. Maybe it's because the selection rate is much lower, which is bad. And so together, those two things, right? Fairlearn also allows us to plot these metrics from the Fairlearn metrics metric frame. Metric frame, blah, 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 blah. Okay. Show metrics, false positive rate. By the way, you're looking at this and you're looking at the sensitive feature. So it looks like the way that these things work, and we got 8 minutes. Oh, by the way, we were trying to see, trying to learn something here while we're waiting for the other thing. Still preparing. What? Oh, it's almost done preparing. So what's cool is you may have a sensitive feature that you could potentially hold out during training, right? Because you can't train on them, or maybe you can. But you can see like false positive rates between men and women, true positive rate, selection rate. There's accuracy, percent recall, and there's the count of the sensitive. And then you can see the true positive rate, selection rate, and count. If we observe disparities between groups, we may want to create a new model while specifying an appropriate fairness constraint. Note that the choice of fairness constraints is crucial for the resulting model. Varies on that. If selection rate is high, relevant for fairness in this constraint, we can attempt to mitigate the observed disparity using the corresponding fairness constraint called demographic parity. In real-world applications, we need to be mindful of the socio-technical context when making such decisions. The exponentiated gradient mitigation technique fits provided classifier using demographic parity as the objective, leading the way. Exponentiated gradient mitigation. I don't know what that is. Oh, look, nice. What do we got? What do we got here? Lecture 10. Exponentiated gradient. We can let me zoom in here. How do we zoom in? Plus. Oh, here we go. Nice. Lectures are drawn from monographs of blah, blah, blah on online optimization. These represent blah, 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 blah. We next consider instantiating FTRL using the entropic regularizer, the negative entropy function with predictions confined to the probability simplex. Concretely, for P belonging to the probability simplex, we take a regularizer to be, this is just a regular regularizer with fancy words. The entropic regularizer is strongly convex, which is nice. The left-hand side is the Bregman divergence of the negative entropy function is equal to this. This is also called the relative entropy or KL divergence. Why are they, they should have just said KL divergence between the distributions P and Q. The KL divergence between two probability distributions measures like if there's two probability distributions, it measures the difference between them. Note that we have blah, boop, doop, mark 1, boop, doop, doop, doop. This is the same as boop. This is famous equality as Pinsker's inequality. It says that the KL divergence between two has to be greater than or equal to the norm 1 squared of the difference between them over 2. Here's a proof. Blah, 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 Pinsker's. What is FTR? This is not even explaining anything to me. I want to know what the exponentiated gradient is. Oh, they're using the exponential gradient to prove something. Well, that wasn't helpful. Exponential. Okay, here we go. We have, oh, shoot. We got 5 minutes. So we got to start putting the closing music on. Online learning with an adversary setting. Okay. So I think what's happening is this is an online method for optimization or demographic parity. So this is the constraint. This is the decision tree classifier. This is the mitigator. Okay. And I think what's happening is the mitigator fights this whole fairness thing to make it more, have better demographic parity. So you see here that there is better demographic parity for selection rates of someone making more than $50,000. I wonder what the demographic parity thing is. So let's go to the user guide. User guide. Okay, here we go. ArcSieve, fair regression, quantitative definition of reduction-based algorithms. This is a study prediction of a real value targets a risk score or recidivism rate with while guaranteeing a quantitative notion of fairness with respect to protected attributes of gender and race. I'll discuss the problem fair regression. Interesting. Show me the maths. Setting where blah. The L1 norm of the loss has got to be less than or equal to. We consider government setting where the training example of triples x, a, y, where x belongs to some x is a feature vector, a belonging to blah is protected attribute, y is the label. So feature vector, protected attribute, label. Another focus on the protected attribute, taking a small number of discrete values. A is finite, but x is a large continuous high dimension. We make no specific assumptions, but blah. Okay. This is quite interesting. We minimize the expected loss between y and such that for all a belonging to all z belonging to y is less than some slack bound. Interesting. Okay. So basically what's happening is they're putting the protected feature into the optimization problem of the whole thing. The slack bounds, they allow departure of the CDF of f of x, conditional density function, a form of CDF of f of x. The distributed CDF is measured in L infinity norm corresponding to Kolmogorov's-Smirnov statistic. Yes, because what happens is, like your model might completely stink. But yeah, all right, so we'll get back to this. We are out of time, unfortunately. It's been a pleasure being with all of you today. Hopefully next time we'll get this part done and let Azure take care of the hard parts. The next episode we've got going on, Greenery Eye with Azure Machine Learning. It's been a privilege and a pleasure being with you. Hopefully we'll see you next time. If you have any questions or need anything from me, you can always reach out to me on Twitter @SethWares, or you can email me Seth.Wares @Microsoft.com. We will see you next time, friends. Have an awesome day.